So moving on, so we created all these lines and we created all these layers with the different line weights. I'm going to turn that one back on. I do want to show you, we spoke earlier about this, is this button right here that shows the line weights. Notice how thick they are now, okay? That means you can put the line weights on and you can see how it's going to look when it's plotted. I do not recommend them staying on because that gets a little distracting. So I just always leave mine off. I just know what it's going to look like when it's plotted just because of practice and knowledge once you get familiar with it. Now, the next thing that I want to talk about is creating our template. We started out talking about the template and going to ACAD drawings. So if you pull this down and you go new, a template is what is in the drawing. So we want to create a template for this class that has the visible, the hidden, and the center line in it, okay? So we want to create that now. So we're going to start with the basics of our AutoCAD, acad.dwt. It doesn't show up as DWT, but it does show it down here. So I'm going to open that up. Now, here's the thing. Excuse me. We also have to create our template starting out to be on the same page as the other AutoCAD class. They have a thing called units. What units do we want to work in? So if we're in a mechanical drafting class or a mechanical class, our units are usually going to be inches, or we're going to do working in millimeters. If we're working in millimeters, then create an ACAD ISO template. When we're working in inches, when you type in units, this pops up. You have decimal types of length. So our units can be decimal. They can be architectural, where you've got feet and inches. You've got engineering, fractional, and scientific. We're going to stay with decimal right now. We may do, we'll do architectural a little bit later. Now the precision, how many decimal places? If I am working with microchips, yeah, I work with 2 decimal places as a civil engineer because I'm working with dirt and concrete. You're not getting any more accurate than that. Not normal.
Mechanical, we go like 3 to 4.
Mechanical, 3, 4. If you're electromechanical and you're working on circuit boards, you're going on 5, 6, 7, or you're going scientific, right? So, but we're just going to stay with decimal. And I'm going to stay with, I'm only going to have 3. Okay, I'm going to be 3. I'll give half to the civil and half to the mechanical. We'll give a nod to both. Our inches. Now, if you open up, for anybody that downloads the Civil 3D program like me, guess what? Our AutoCAD template is in feet. So there's a 1 to 12 scale, okay? But in this class, we're only going to be using in inches, okay? So this class is only in inches.
Yeah, see, that's basically because the drawings are so small.
Exactly. Our drawings are so tiny. When we're talking about civil engineering, we're talking about miles of roadway. You're not going to measure it in inches. You're not going to build it in inches. You're going to build it in feet and miles, right? Now, the other thing we're not going to worry about biting. The other thing is we've got decimal degrees. So mechanical engineers are going to be decimal degrees. Civil, we usually do degrees, minutes, and seconds as a surveyor. As an engineer, I'm OCD about all my decimal places on my decimal degrees. I want my decimals. We're going to leave it in decimal degrees. Now, we have a precision, and we're going to take it out to 3 also.
The grades was that's civil, huh?
Mm-hmm. Yeah. Graduate, yeah. Now, here's the thing. In math and in AutoCAD, our drawings are always drawn counterclockwise, okay? Counterclockwise. If my arm here is the horizontal plane, 0 is at my fingers, and it goes 90, 180, 270, 360, okay? You can tell it to go clockwise, but if the 0, 0 axis here, if I'm drawing zero is here, okay? If I'm rotating, 0 is this way, 90 is straight up, 180, 270, back to 360. Okay? We are going counterclockwise as an x-axis as our 0 origin, 0 east. Okay? When you get into survey, that is totally different. We'll draw it this way because they force us to, but we think differently in survey. All right? Now, enough with that. So we've got our units set up. We've got our decimals, we are in inches, and we've got the precision. Now the next thing that we need to set up in our template, I'm going to delete that for right now, and I'll show you how to do that in a minute. The next thing that we want to do is what we call limits. Now, we type in limits. The limits of our drawing. The grid shows you the limits. It goes 0 in the bottom left corner to something in the top right corner. So we're going to say 0, 0 for the bottom left, and right now it's 8.5 or 11 by 8.5 in the top right, which is fine. So I can just hit enter. Now, when you're at home, April did a video on this, and I'm not going to cover it because her video is fine, and I'm going to let you all watch that. If this doesn't look like it at home, watch her video on how to make your sheet look like this. It's not a world ender if it doesn't look like this. This is just a setup, okay? This is just the start of our drawings. Now here's the thing that I have to say about limits, and I say this because your other CAD teachers will say, well, what are your limits? Set up your limits. Mechanical and anything mechanical, electrical, mechanical, I can see that you have limits because your objects are tiny and it's going to fit on an 8.5 by 11 sheet of paper, right? If I put limits in civil, I have a mile of roadway. That's 5,280 feet. It's not going to fit on 8.5 by sheet of 11 paper, right? I don't even bother with limits. I've never set a limit in my life in civil. Architectural, maybe they want their, no, I don't even see it in architecture, because you're talking about a building that's 1,000, 10,000 square feet. So no, I don't see limits being used there either. But in this class, just to get you orientated to this is where you should draw, just to start with. So mechanical, did Bob Watson use those in mechanical? Okay. Yeah. Even some of our other drafting professors don't use limits. But I give a nod to limits because other drafting professors do. And it is a nice grid area for you to start drawing on. Okay? Now, excuse me. So now we've got our unit set, our limit set. Now we're going to start on our layers. So I'm going to click on layer properties, and the first one I'm going to create is visible. I am going to, let me take a look. In the homework assignment, let me see what it has set. It doesn't have it, but we're going to go ahead and say, you can change these anytime. I was just looking through the first homework assignment to see if you had to put the layers in, but it's not. But I'm going to go ahead and say, let's make the visible red. And let's make the hidden, we'll go out and say that is going to be blue. And we'll go ahead and load our hidden line.
Light blue or dark blue?
Pardon?
Oh, you got two blue.
And then I'm going to pick hidden 2. Go okay. And I'm going to go ahead and I'm going to say center. You can add to these. So the center, let's make that cyan. Go ahead and load. And we'll go center. I can't spell today. Center 2. Okay. Okay. Now I'm going to create one more, and I'm just going to say text. And I'm going to put that on continuous, and I'm going to put one more and call it dimension. Dim. All right. I'm going to leave those like that. those are the layers that we want to start out with. So you don't have to create this every time, but you can always add to your drawing. Okay? You don't have to. Anna and I will come around and help work on this with you all. The other thing is make sure that the plot is not marked as a block. So there's no symbol here. Okay? Now, the last thing that you need to do is you're going to type in, I want this orientated so that it's dead center of my view. So here's one more command. It's zoom. So you can type in Z for zoom. That means I'm going to view a certain area, zoom. And April uses all. I actually use Z and I use extents, E for extents. It does the same thing. The reason I use extents is because sometimes when the surveyors bring in data points, one's literally in left field. And I need to see left field, and most of them are here. So when I say extents, it gives me the entire
What
picture.
about having a drawing sent to you and you put it on your screen and it's like,
Yeah, exactly. So the last thing that we have to do is go File. We're going to pull the arrow key down and go Save As. And now we're going to save it. You can save it to your desktop and email it to you. Now, you can save it as a DWG or a DWT. If you save it as a DWT, it's always going to path to your C drive. It will automatically path to your C drive to a specific place. So I have no problem with you saving it as a DWG, and it might be a little bit easier for you. So I'm going to save it as template dash bowling, and I'm going to save it as a DWG. Now, anybody that has previous versions than 18 can save it down to a 13, and then you can open it up in 2016, 2017, 2018, etc. All right? And then click Save. Now you have your template saved. All right? So we're going to pause there.